welcome back to the channel. In the previous video, we have seen the concept of Narx Neural Network, its parameters, and how it functions. If you have not yet seen that video, you can find the link of the video in the description and have a look. In this video, we will discuss how we can use the same code for developing a simple rainfall runoff model which can predict 1 day ahead discharge and also multiple day ahead discharge. So we will begin with talking about how we can make the data so that we can develop a good runoff model. So let's directly get into it. So beginning with developing the data, I already placed the data in an Excel sheet where we can see here that the first column of the data represents the current day's precipitation and the discharge is represented in the second column, while the third column represents 1 day ahead discharge. Understand that it is a 1 day ahead discharge based upon looking at the value of its first row, where we can see that it is 13.725, same as the row 2 of the current data. So we will use this simple data to try and understand how we can develop a good Narx model. So the next step in developing the data is to know how many lags which we can use so that our model is good enough. So we have already discussed this concept in our previous video where we talked about the concept of correlation, which deals with determining how many lags we need to get a good information for developing any model. So if you have not yet seen that video, you can find the link of the video in the description. I advise you to watch that video because I will not go in depth of details in this video. So the basic thing which we'll be looking here is to see what the result of that correlation analysis shows and how we can determine the lags. If we see the result of the figure here, we can see that it points out how the lags are varying and what the correlation of each lag is. If we look at the center, we can see the zero lag, which is having a correlation of 0.35, which represents that if you use zero lag, the correlation between the variables is 0.35. And as we go down, we see that the correlation is decreasing and it reaches until 0.15 for fourth lag and then increases. So based on the understanding of our previous video, I take the value of lags so that we can develop the model and see how it is working. I think the number of lags will influence the accuracy of the model. Hence, it is better to keep a keen eye and check if it is capable of giving you a good result or not. After successfully determining the lags, we can go to the Excel sheet where I have already prepared the data so that it is easier for developing the model. So if you see here, the first two columns represent again the normal data where the remaining columns determine the lag components. How we can identify the lag is we see that I have left 1 row, 2 row, 3 row and 4 row for all the discharge values placed after the original values. Similarly, I have done the same thing for precipitation. Observation, we can see that the values of the lagged are not even with the ones of original. So the thing we do here to make all the components of same length and prevent any issues for developing the model is cut all the excess values so that the model does not have any issue for understanding the relationship. Once we remove the excess values, we can observe here that 8.5 becomes the current day's value because we need a lag of 4 days which are represented by the values of 14.743, 13.725 and the remaining 9 values which are prior to 8.5. So the current day's value becomes 8.5 and the remaining values are the past information which we'll use for developing a model. To simplify it, I've already placed all the data in an Excel sheet as we see here. The first 10 rows represent our input data with first 2 columns representing our current day's precipitation and discharge, the next 4 representing the past discharges and the remaining 4 representing the past precipitation data sets. We have understood that these 10 are our inputs. The next thing is to determine our training target data, which is 1 day ahead data. The simple thing which we did is copy all the values from the second row of the current day's discharge data and put it in the last column and use that information as the training target as well as during the testing points. One thing to keep in mind while completing the preparation of data is after pasting the target data set, because we left the first value of 8.5, the values of the target data set's length is one row lesser than the original input which we want. So the thing which we do is remove the excess values of the input data by removing the last row of the inputs. Doing this, we make the length of both input and target same so that we do not have any issues while developing the model. The next sheet, we can see that I've just pasted the data set of same length so that we don't have any issue while importing the data into the Matlab. The 10 columns are put under a name of input, whereas the remaining one target column is named as target. After successfully importing the data, the next thing we need to think about is dividing the data into training and testing sets, which we'll use for training the model and also see how it is simulating the result. Before developing these data sets, the one thing we need to remember is here the rainfall values are in mm, whereas the discharge are in meter cube per second. So hence the discharge values have higher potential to be of higher values in terms of 4 digits compared to a rainfall value in 3 digits. So thereby when you are developing a model, the model cannot understand the relationship between both the data sets easily because it does not know what is rainfall and what is discharge. It just sees the numbers and tries to develop a good relationship. So the one thing which we can do here is normalization of the data. We have already developed a code for normalization and also applied it for a case. If you have not yet seen that video, you can find the link of the video in the description. So we will just directly use that code and normalize the data and also replace the name of each variable after we normalize the data so that it does not replace the already normalized data and put a new data in it. So after the data is converted from 0 to 1, the next step is dividing this input and target data sets into training and testing sets. This thing we can do by simply writing the lines as you can see here on the screen. By using these lines, we can divide the data into different sets. In this case, we'll use the 70-30 ratio so that we can divide the 70% of the data into training and the remaining 30% of the data into testing. We name them as train input and train target for our training model and test input and test target for our testing model. Once we have divided the data into testing and training, the next thing we remember is that while developing a neural network, the neural network only understands and tries to make the model when it is in row matrix format. So if we see here, we have a column matrix with our data sets in columns. So we divide the data into row matrix. We can do this simply by putting a inverted comma after the data set we want to transpose. So this line we can use for transposing the data, or we can do it manually by double clicking in the data and going to the variable tab and clicking the transpose function. In this way, we transpose all the data sets so that it does not have any issue while developing the model. You can also do the same thing in the code of the model, but I'm just showing you so that you remember this step so that you don't forget to replace the data set in a matrix format. After we have successfully developed the data, the next step is to run the model. So if you see here, you can see the code which we have talked about in the previous video with slight modifications. I've modified this code so that we can develop a model which can predict 1 day ahead and also multi-day ahead discharges which I'll be modeling. So in order to do this, we use a different approach of developing a Narx neural network where we'll be using NarxNet which is a closed loop system. If you remember in the previous video, we discussed that there are two systems which are open loop and closed loop, where open loop is used for general modeling, and whereas the closed loop is used for a multi-step ahead prediction models. So in this video, we'll see multi-step ahead prediction using a closed loop. The lines which I have added additionally are these two. For example, this convert the matrix data which we have into cell formats, because Narx neural network uses a cell format to understand the relationship between the variables and run the model. So along with this, you can see here up till here everything is same as what we saw in our previous video, where here I have just converted the result I am getting from the model in the training phase, which I have named it as Y, into a matrix so that I can compare with my training data. So this is the code I am using to compare my predicting result to that of observed result. If you remember here, we have already discussed this code in the prior videos, which was developed by IHE Delft with many parameters such as RMSE and correlation. If you have not yet seen that video, you can find it in the description. So after knowing the result of the training, the next step we do is we use this closed loop so that we can do prediction. So here we use the same parameters which we have used in the training without changing anything, and develop a closed loop such that we can predict the multi-step ahead or one day ahead discharge values or any other parameter values which you might be interested in. So this is the code which we'll be using for this work. So now let's just run until the training phase and see how the model is running. So until this line is training, because here we find out all the error parameters. So I'll just run all these lines, and you can see that when this is run, the model is running here with number of iterations. I've increased these iterations to 1000. If you can see here, generally they would be only 100, whereas I have increased the validation checks also for the model to be able to run for quite a few runs and understand the relationship better. So if you see here, the correlation of the parameter is 0.5654 and the error is 0.03. So the thing which we will talk for now is only the correlation. The correlation, as you know, it represents whether the prediction of the model is following the same pattern as the observed. So by this we can say that 56% or 0.56 confidence limit that it is following the same pattern. One thing you can do is you can run the model again to see if you can get a better result, because every time you run the model, it tries to develop a new relationship. It changes the weights of the model, thereby giving you a different result. So I would advise you, if you get a good result at the first time, better save that network and also the model with a different name, so that you don't replace the results again and you don't get the better result again. If you see here, it is again increased to 0.5883. For the sake of this video, we will say this is good enough, but in the real case scenario, when you are doing research work, it is advised to have a better correlation more than 8.5, which is 0.85 or more. Sometimes it is not possible because maybe the parameters are not having a good relationship with another. So it depends on case by case, but generally anything above 0.8 can be considered a good correlation. And also you can check further the RMSE value which you are getting in the model which you will be developing. So for now, if we say this is good enough, the next step is to run the remaining lines so that it can give the simulation. Because until now what we have done is we have just trained the network and we have compared the training results. So now we are simulating, that is testing the model. We are giving a data which we have not yet shown the model. So this data is independent of the training data set which we have created in the prior with name test train and test input. So we'll use the test input here. If you see here, I have already made it into cell format with W as its name, and I have used it here for prediction. So now I just again run these lines and you can see here it ran very quickly compared to this because the length of the data is quite small. So if you see here, the result is 0.6109. So a general thumb of rule is most of the time we want the result of our testing set to be better than training, because when you have trained the model in a perfect manner, the testing result would be far better than the training model. So in our case, this is giving a good result compared to our training model. So we can, if you are not satisfied and you think it can do better, you can still again run. But if you see here, we are getting this result again, which is 0.6109, which might be the best result we might get. It again depends on how many times you want to do and how much accuracy you need in this model. So in this way, we can use these lines of code, which we can use for 1 day ahead prediction. So until now, we have seen how the model is doing for 1 day ahead prediction. We have seen that testing is doing well. So now let's do one thing and do a multi-day ahead. Like we'll do a 2 day ahead discharge prediction. In the same way, we have prepared the data for 1 day ahead. I've done the same thing for 2 day ahead. If you can see here, this sheet represents the 2 day ahead rainfall, where you see the target data which I am asking the model to predict is 2 days after the starting day of our analysis. So let's do one thing. We'll take this data into Matlab and see how this is working. So first, let's clear out all the data here so that we don't have any issue. For this sake, we are not saving any data because it's for explanation point of view. But in your case, I'd advise you to save everything, because once you forget to save something and you don't get a better result after it, then that will be the worst case scenario. So better save everything after every run which you do. So we'll just paste this input data sets. The length would be lesser because we are using 2 days ahead. So our original data is again reduced by 2 days. And then let's just paste the target data. So after just pasting the data, the next step is to normalize the data as well as get it into training and testing format. So I've just compiled this code in such a way that we can just do the same thing here. So the one thing we need to change here is 4713 and 4713, because we reduced 1 day, and we are not changing the 70% because it's almost similar to this, which will be around 3304 point something. So we'll just run this code, and we can see here the test and training data set are formed. So the next step is just again running the training model. If you see here, it again started running. So one thing I'd advise you to remember is, as you go on trying to predict a higher or multi-day ahead predictions, the accuracy generally decreases as you increase the number of days you want to predict ahead. So keep that in mind while doing the model. And yeah, if you see here, the result here is 0.5887. If we remember in the previous model, I think it's 0.5896. Although we can improve that result by changing many parameters, like for example, we can change the hidden layers to find out the best hidden layers, or we can change the parameters of the input delays and see if a higher delay is giving a better result. So you can play with these two parameters and see if you are getting a better result. But in this case, I have done many models before fixing these parameters. So I'm using these parameters for this data set, because it also depends on the data if the data is having enough information for you to make a better model. So I have seen that this is the training result for 2 day ahead. So let's just try to predict. So this is the testing result. Similar to what we did for 1 day ahead, this is the testing result for 2 day ahead. And you can see here the correlation is better than the training, but in the previous step with 1 day ahead, we had 0.6109 as the correlation of the 1 day ahead. So you can see here the 2 day ahead has a lesser correlation, because as the lead time increases, the accuracy decreases. So in this way, we can use this code for developing a rainfall runoff model or any hydrological model with varying number of parameters. For example, here we have used only simple rainfall runoff model. You can take it into a next step by taking any other variables, like for example soil moisture or optimum moisture content of the soil, etc., and see how this model is able to predict those data set. So this is the simple concept about the development of rainfall runoff modeling, and also doing a 1 day ahead and 2 day ahead discharge prediction. So I hope everything is clear in what we have done in this video. If you have some doubts regarding how we prepared the data and also about the error code, I would advise you to look into those videos which are in the description. If you have any doubts and if you feel something is not clear, kindly text me in the comment box. I'll try to clarify the doubts as soon as possible. So that is it for this video. If you have understood the concept, give this video as a like, subscribe to the channel, and share it with people whom you think this information could be useful.